Alright, we're going to be dealing with transformations, and specifically transformations of parabolas that are in vertex form. And when I'm talking about a translation, what I'm actually meaning is we're going to be taking the graph, a parabola, and we're going to be shifting it, moving it around. Translation just means I'm taking this original graph, whatever that is, and I'm moving it maybe to the right, or I'm moving it to the left, or I'm moving it up or down. There's all kinds of different transformations that we can make when we're dealing with the graphs of a parabola, and there's different ways that I'm going to change that. And I want to look at how we would actually change the graph of a parabola in vertex form. Now the first thing I want to look at is the A term. If I make changes to the A term, one of the most common would be a reflection, is what we call this, a reflection across the x-axis. Okay, and you'll see it called a reflection because it looks just like a reflection of the parabola. It's just flipping it over. So it's a reflection across the x-axis. Now what I mean by that is if I were to take this parent function, as you can see, this is the graph of y equals x squared. If I was going to reflect that, all I would have to do is make the a term negative. If I were to take this x squared graph and make it negative x squared, it's going to create a reflection across the x-axis. It's not changing the shape, it's just reflecting it across the x-axis. So wherever this graph was, if I make the a term negative, it's going to flip the graph. So if the graph had been up here and I made it negative, it would just flip and it would then be reflecting horizontally. Okay, so I'm just reflecting it over that horizontal axis right there. Alright, now that would be a reflection across the x-axis. Okay, now there's another thing that's going to do. If I change the a term, if I were to make it a bigger number, let's see, if I made a greater than 1, that's going to create what we call a stretch. Okay, so if this a term, for example, down here in our original graph, the a term in this graph is just 1. This is just the graph of x squared. But if I put a number in front of that, let's say I made this 3x squared, it's going to create a stretch. Okay, and you could check this out on Desmos, how this would work. But it's just going to make the graph more narrow. Okay, so if I were to take the original function, make the a term bigger than 1, the bigger that a term gets, the more narrow that this graph is going to become. Okay, so and that's what we would call a stretch. Now you can also make the graph wider by making the a term smaller than 1, and that's what we would call a shrink. So I can not only can I create a stretch, which would make this parabola more narrow, I can also create what they call a shrink by making the a term less than 1. That creates a shrink, and it just makes the parabola look wider. Okay, so that's the difference there. So if I took the graph x squared, and let's say I made that graph 1/2 x squared, all it's going to do is make this wider in both directions. Okay, so as those fractions get smaller and smaller, the graph's going to get wider and wider and wider. If the numbers become negative now, it's going to create a reflection like we just saw. But as these numbers get less than 1, they start approaching 0, the graph's just going to get wider and wider, and that creates what we call a shrink. It's like it's getting flattened out. Alright, now changes to the h, to this number right here, are just going to shift this graph left or right. This is just side to side. That's all that this is changing. Okay, but now it's going to help to understand that this negative is in the formula in vertex form. There's a negative there. So if you see negative h, or let's say for example, let's say this is my parent graph down here. If I were to make a change to this and make it x minus 2 squared, this 2, even though it looks like a negative 2, which negatives we usually think move to the left, this is actually going to move this to the right. because the negative, when you look at the formula in vertex form, there's a negative here. So whatever number you put in there, it's going to shift it to the right if it looks like a minus something, whatever that number is. Okay, so in this case, -2 would shift this graph. It would just take the vertex and it would move the graph over 1, 2 spaces. The graph's not going to change shape. It's just getting moved over from where it was. Okay, so that number right here moves me to the right. Now, if it's going to move me left, you would take x squared and you would add. It would look like x plus 2. Okay, plus 2 is going to move me to the left 2 spaces from where I started. So when we're talking about those horizontal left and right shifts, they always kind of look like the opposite of what you would think. Negatives move you to the right, whereas it looks like this plus 2 moves me to the left 2 spaces, and that's just because there's a negative in the formula, and so technically we put a -2 in here, but the negative in the formula made it look like +2, and that's why this appears to shift, why the positive moves you to the left. Okay, so the changes to that number there, if you needed to move a graph, it's always going to look like the opposite. Now the easy one is this last number right here, the k term. It just moves us up or down, and it's going to do exactly what it looks like it's going to do. Okay, so if I were to change this graph, let's say I wanted to shift it down, starting out with x squared, and let's say I made that x squared -2. That's just going to drop it straight down 2 spaces from where it's at. It's not going to change the shape or anything like that. It's just going to take this graph and it's going to drop it down 2 spaces. Alright, so if I wanted to do multiple things to this graph, let's say my parent function was x squared, and I wanted to move it left 2 spaces, okay, left 2 spaces, and right, and up 3. Okay, if that's the transformation I was wanting to do to this parent function, left 2, up 3, my new function would be left 2 is always going to be plus. Okay, it's always going to be the opposite of what you would think. But up 3 is just going to be +3. That +3 is going to move me up 3 spaces. The +2, that's moving me to the left, and this is moving me up. Okay, so I know my graph's going to go left 2 spaces, then it's going to go up 1, 2, 3. My new graph just shifted left and up. It's still the same shape. I did not change the A term. I just moved where it was. I moved it left, I moved it up, and that's how these transformations are going to work. Okay, and the most complicated problem out there you would see would just be changing all 3 terms. Let's say that I had my parent function x squared and I wanted to reflect it across x, and I wanted to move it to the right 3, and then I also wanted to move it down 2 spaces. Okay, if that's the transformation I want to make, okay, to reflect it across the x-axis just means to take it, x squared, I'm going to make it -x squared. Okay, and to move it to the right 3 spaces, that's going to look like this. Okay, it looks like a -3. This is what's going to move me to the right. Okay, this is what caused what we call a reflection. Okay, so it reflected across the x-axis. I've moved it to the right, and let's say I want to move it down 2. That's the one where it just -2. That's what moves it down. Negative goes down, positive goes up, just like you would kind of think that it would. So when we do transformations, we're always starting with that parent function, this blue parabola right here. Now we're reflecting it, but not only are we going to reflect it to where it's moving, to where it looks like this, we're doing 2 other things. I'm reflecting it, I'm moving it to the right, and I'm moving it down. So we reflect it, we move it right 3 spaces, 1, 2, 3, and we move it down 1, 2. So it'd be about right there. My next graph, after it's been translated, would be down here. So it went down and it went to the right. Okay, so we have this graph that went right and it went down and it got reflected across the x-axis. So that's the kind of transformations that we can expect to see. And I want to show you what that's going to look like on the homework. If we go down, this is what the first question is on the assignment. They give you a graph and they say it's negative x squared is shown. The equation is changed by, and they show you what's happening right here. That you just need to understand that that negative 1 is actually moving you to the right one, because it always does the opposite of what you would think. And this one does exactly what you think it would do. This is going to move you up 4. So you're telling what type of transformation is taking place as you move from the negative x squared, it was already reflected, to this new function over here where they kept it negative so it wasn't reflected. If they made it positive, it would have got reflected, but they didn't. So all it did was move right 1 up 4. Okay, so that's what's happening here. This thing is shifted right 1 and up 4, and you're just kind of describing that. Okay, all right, and you'll also see questions like this one, where you've got the graph of x squared, and it says if the equation is changed by, and look what they changed. This was positive x squared. They made this negative. That negative right there is reflecting across the x-axis. Okay, so you can see that, and that plus 3 is just moving it up. They didn't shift left or right, so they don't have anything inside. They got x squared. They didn't take away from it anything, so it didn't shift. So it just still looks like x squared. But they did do something here. They did add 3. So they reflected it across x, and they shifted it up 3. Okay, so this is getting shifted up 3. Alright, and that is how this is going to look on a test or homework. You're going to see where you start out with your original function and they give you the new function, and they're asking you to describe what changes have taken place. How did it change from what it started out as right here, to what it ended up as? So for example, here in that first one, we started out just like this, with this parabola that was opening down. All they did here was they moved it in 2 directions. Just make sure you understand that that negative 1 is to the right, that positive 4 is up. Okay, that's the way they're moving these, are going to be moving these around.